Now, how long will each take to get to 50,000? Well, it's a similar question because you're using the same equations. You're just setting them all equal to 50,000, and it's done differently depending on which one you're looking at. So equals 50 or 5,000 times 1.06 to the x power. How long will it take? You divide by the 5,000. We're going to do that with a couple of these. So you divide those, and 50 divided by 5 is equal to 10. So now you got 10 equals 1.06 to the x power. Okay, if you take the log of both sides, log, the x goes out in front. You got log of 10, which is equal to 1, equals x times the log of 1.06. So really we're dividing by the log of 1.06 to get our answer. So let's do that. You got 1 divided by the log of 1.06. And that's going to give me 39.5 years. 39.5 years. Now option B is a little less this chapter because we're setting that up, and it's a linear equation, 5,000 plus 300x. So we're subtracting the 5,000 instead of dividing by this in this case here. So that's a 45,000 equals 300x. So you divide 45,000 by 300, you get a what? 150, I think. 45 divided by 300. Yep. So we got 150 years. Yeah, that's a lot. Compound interest makes a big difference, obviously. So you set the same thing. You got the 50 grand equals 5,000 times e to the 0.05x. So when you divide by the 5,000, you got 10. Okay, you got your 10 equals e to the 0.05x. Natural log of both sides, get the natural log of 10 equals 0.05x. You do your divided by thing, natural log of 10 divided by 0.05, and you've got yourself 46.05. So it's going to take slightly more, well, more years, about 6 more years than this, 5.5 years, 6.5 years, to make it more there. So there you go.